This lesson we will be sketching parabolas by completing the square. Now, any quadratic that we have in the form y equals ax squared plus bx plus c can be expressed in what we call turning point form. Now, turning point form takes the form of y equals a x minus h squared plus k, where the turning point is at hk, so you can see the h and the k there in turning point form. And when the a is positive, we have a minimum turning point. When it's negative, we have a maximum turning point. So that's the same as when we did reflections a couple of lessons ago. That a value there, if it's negative, it's a maximum turning point. If it's positive, we've got a minimum turning point. So that's turning point form, and that's the form that we will be focusing on in this lesson. Let's jump straight into an example. So, sketch by completing the square. For completing the square, I'm just going to abbreviate that to CTS. Sketch by completing the square, y equals x squared plus 6x plus 15. Now, obviously, in order to sketch by completing the square, you need to recall how to complete the square, so hopefully this would be a good reminder. To start with, let's just write out our equation as it is. So y equals x squared plus 6x plus 15. If we want to complete the square, this will become y equals x squared plus 6x plus 6 over 2 all squared. Remember, it's b over 2 all squared. Our b here is 6. Then we need to balance it out, so we subtract 6 over 2 all squared, and then we've got that 15 at the end. And just to make it a bit clearer, I'll put the brackets around there. Alrighty, x squared plus 6x plus 6 over 2 all squared, what we've done is we've created a perfect square, so that becomes x plus 3 all squared minus 6 over 2 is 3, 3 squared is 9, so minus 9 plus 15 will give us plus 6. Alrighty, so we've got our parabola in turning point form. Remember, turning point form is y equals a outside of x minus h all squared plus k. And hopefully this form here actually looks familiar to you from the transformations that we did a couple of lessons ago. The turning point is at hk. So we know our turning point for this parabola will be at minus 3. This x plus 3 slides it to the left. 3, minus 3, and 6. And once we've done the turning point, we need to go ahead and find the y-intercept and the x-intercepts as we would for parabola in its general form. So let's go ahead and find the y-intercept. We know to find the y-intercept we let x equal 0. Now, it doesn't matter which rule we use to make x equal 0. We could let x equal 0 here, or we could use our original rule here. It doesn't matter. I'll use the original one. So y equals 0 squared plus 6 times 0 plus 15, y-intercept of 15. Now let's find out x-intercepts by letting y equal 0. I'll use the turning point form to find our x-intercepts. So we'll get 0 equals x plus 3 all squared plus 6. Now, if we rearrange this, we'll get x plus 3 all squared equals minus 6. And what we get from this is actually no solution. Now, the reason for that is there's no way that we can square a number and get a negative. And if we come back to our turning point, we've got a turning point at minus 3, 6. Just picture that on a number plane. We're at minus 3 and then up 6 at positive 6, and we've got a minimum turning point. So there's actually not going to be any x-intercepts on this parabola. So that's why we've got no solution. Now let's go ahead and sketch this using the information we know. Alrighty, so I've gone ahead and sketched that parabola in turning point form. So when we got it in turning point form, we found that the turning point was negative 3, 6. So here we've got our turning point at negative 3, 6, and we found our y-intercept to be at 15, which I've labelled here, and we found that there were no x-intercepts. So, and we can clearly see that from the parabola, it's lying above the x-axis.